Good morning. My name is Marty Bryne. I'm with RPI Center for Future Energy Systems. It's a pleasure to be here this morning to have an opportunity to talk to you about renewable energy. And my premise today is that the time is now. The Center for Future Energy Systems is one of the NISTAR-funded CATs around the state, Centers for Advanced Technology. And we want to be, our specific focus is in a number of the renewable energy space here. All right, let's see. Okay, so again, we're the Center for Advanced Technology. Our main goal and objective is really to find and work with industrial partners around the state, facilitate the technology transfer. And when we can, we work with company partners to go out and try to find STTR or SBIR type funding opportunities. NISTAR has invested about $109 million in the various CATs around the states over the last 10 years. And the impact has been very positive, over $4 billion. And you can see here 5,000 jobs, about $1.6 billion in increased sales, and about $700 million in company cost savings. So these are pretty substantial results. Our center, in particular, we focus on these technology areas. If you look at renewable energy, it's going to be in the wind, solar, thermal photovoltaic, solar thermal as well. It's nice to hear the thermal vault presentation and net zero. We also have a laboratory that works in fuel cell area. Electrodes, membranes, catalysts, we're doing some work, testing and characterization work. We'll talk a little bit about that later. Energy efficiency, smart lighting and displays, as well as buildings. And again, I'm going to go through some slides here a little later to give you that. On campus, we also won a $1 million award to do distributed energy testing, distributed energy resources and how it impacts the grid. So we have a simulated test bed on campus. And we also have some expertise in our electrical lab where we're doing phasor measurement units around the state and around New England. And last but not least is something new. We partnered with Syracuse and Stony Brook for the regional hub for New York Energy Policy Institute. And so we're coordinating and we'll be kicking that off at the Advanced Energy Conference in November. So these are some of the things we do. We work with Cornell as our partner. We share the funds from New York State with Cornell. But we've also reached out to Clarkson, Syracuse, Alfred over the years on CAT development projects. And we've done some work with both of those colleges. So again, my role really is to go out and try to get sponsored company research agreements with industrial partners. And if we can, do technology transfer and licensing as well from some of the intellectual property that we have on campus. And work with companies even on business plans. We worked with Ioxis out of Oneonta to put their business plan going back for supercaps. But I had the fun job, I guess, today of talking about renewables in a little bit different detail than I normally do. So that's really what I wanted to do today. And I want to go back and talk about three areas really. We're going to go through the renewable space and where some of the current technologies are and where they're going. We're going to talk a little bit about funding and where the opportunities are. But first of all, I guess I want people to think about a world without oil. And I don't know, the first thing that comes to your mind when you think about that, I was kind of fooling around and said, Mad Max is one of these crazy guys. It talks about that movie, Social Collapse. It's based in Australia and how wild things got. The reason I bring this up is because it was a premise that came up on campus in our School of Management. And as such, I wanted to go back and research, well, what does a world without oil really mean? And when is that going to happen, potentially? So, as all good search engines are out there, you start with Google and you always goes to Wiki. And if you look up peak oil on Wiki, you'll get 196 references. And it's very interesting reading, and it was a sidebar for about 2 days. Luckily, my boss was out of town. But you know, if you look at this, a guy named Hubbard back in '56 put together. He was wondering about the U.S. mix of oil and when it was going to run out, and then subsequently it's been a global model. It's a base model. It's not specific, but you know, it shows, you know, way back when, you know, you had this first one was done in 1950, and you can see what their proven reserves and what their future discoveries and what they thought. And that peak is somewhere around, well, right about where we are right now. There's more recent work that's going on. This is a peak oil, by the way, is a definition is maximum rate of global oil production. Okay. This other curve is a depletion curve. This shows you when oil potentially is going to run out. And you can see that depending on where you are, who you are, if you're T. Boone Pickens, if you're the Saudi Aramco, if you're BP is quoted in here quite extensively, and they do a really good job of putting together information. And there's another company in here, the Columbia Energy Research Association. So depending on your view, oil, if you're an optimist, 2020 with a maybe 100-year plateau. And we've already gone through 1.1 trillion barrels, and that there's probably 2 trillion barrels more out there to be had. And if you're a real optimist, you might even say 13 trillion. But that's really stretching everything. If you're a pessimist, you say it peaked already, there's a 3% oil decline, and that's on conventional oil. Now, conventional oil, what's conventional oil? Well, what it's not is oil shale, it's not oil sands, it's not biofuels. So all these would be additive to conventional oil. And again, CIRA has a pretty good optimism here. They say that we're, and I'll show you some slides, but 100 million barrels per day with 80 to 110 going through 2030. And YTF is yet to find resources. So they're basing it on some optimism, obviously. There's another study that the government did back in 2005, the Hirsch Report. The Hirsch Report's interesting from the standpoint that it talks, and I'll just summarize real quickly here, that it's going to happen within a decade, that the economies are going to be very impactful, especially in the United States, that it better not be abrupt because that could be a revolutionary kind of problem and issue, and that we need to find fuels for transportation and large amounts of substitute fuels for transportation. So renewable energy, time is now. Right now, the U.S. consumes about 18.7 million barrels per day. The number to remember is about 286 billion gallons per year. That's going to be important later. If we say that 2/3 of that, or about 190 million gallons, is oil, or I should say is gas and diesel, and probably 150 billion is the gas part of it. Keep those numbers in mind. But again, you know, fossil fuels are exhaustible, and we haven't even talked about the climate change impact yet. So what's happening out there? Well, here's the U.S., and this is, again, 2009 top global users of oil. And over here we have China, 8.6. China had the capacity to build 5 million cars going back to 2005. Anybody want to guess on what their capacity is today? 13 million cars. So in 5 years, they've almost tripled their production of automobiles. So the projection is that this circle over here is going to be something like that in pretty short order, and with plans to continue production of automobiles, granted smaller automobiles. The same is true of India, which is right here. So at 3 million barrels per day, that's going to rise substantially. Interestingly, our projection for the United States is going to go down. Probably in 2030, it'll be down 30 to 40%. So that's pretty amazing. We've had the recent incident out in the Gulf that everybody's well aware of. So that generated about 140 million gallons, about 6 hours of usage here in the States. But you know, had a tremendous impact and got a lot of people out there really touting conservative views on oil production. And of course, we all remember the Exxon Valdez. So that was about 1/10 of the size of the spill that we had in the Gulf. Why renewable energy sources? Every time we get a hiccup, and we know this from the OPEC oil embargo or the Iraq-Iran war, we get these major spikes, and of course they correlate with the price of a barrel. So price sensitivity is a very important issue when it comes to our supply and demand situation. And then the last but not least is the global climate impact. And you know, we've talked about fossil fuels. 81% of our energy is derived from fossil fuels. So that's coal and oil, the major players. And you can see that, and these numbers are a little light, I think. This is going back to 2000. But, you know, we're talking about cumulative 9 billion tons of CO2 per year. So, just to recap a little bit, so U.S. petroleum, about 69% of that goes to convert to gasoline and diesel. U.S., we long ago went through our maximum, but there's certainly now some new renewed interests out in Colorado, what they call the oil shale deposits, 1 trillion barrels. We also import about 3 million barrels from Canada. I've been up to the oil sands in the Athabasca region of Canada. It's pretty amazing to watch them mine oil, and it's a pretty efficient operation. And they can do it and make a lot of money when the price of a barrel of oil is $50 to $60. The other thing about oil, too, is that the U.S. refining capacity is about 90%. So I've got a lot of slides here to get through. The whole idea of the petrochemical side of this, the 30%, what we do, you know, my polyester suit I wouldn't be wearing, all the plastic cups, the styrene, the aromatics, all your base polymers, plastics, your fibers. So all those supply chains have to be figured out in a world without oil. Let's just talk real quickly about electrical capacity. Right now, the way in the U.S., we have coal representing 49% of our mix. If you look in New York State, it's only 14%, just for curiosity. Nuclear is 19%, and in New York State, again, we're blessed with or I should say a higher level, 29%. Hydro, 7% on a U.S. basis, 17% on a New York State basis. We're higher on petroleum than most, though. So 2% U.S.-wise, New York State about 16%. So that petroleum is another potential area that we're going to have to make up for electrical energy production. I have this in here just to explain to some of the rookies, you know, what a gigawatt and a watt, and but just to let you know, the key ones here, like our largest building on campus draws about 800,000 watts, almost a megawatt. And if you take the bridge or the dams out at Niagara Falls, there's 5 of them. They produce about 5 gigawatts of energy. And in the U.S., we need about a terawatt. So right up on top, 1.1 terawatts is the amount of energy that we need. Okay? That electrical energy, I think if we look at residential consumption, is a major part, 38%. And we're glad Thermovault is working on the HVAC part of that. So that we can reduce our energy usage there, 31%. So that's a major part. Another major part that is undergoing a substantial change is lighting. If we look at the commercial sector, you can see lighting is a big component of it. 38% of our electrical energy goes into that, and 30% into heating, ventilating, air conditioning. So these are important sectors for us to take a look at and come up with building efficiency models and really work hard at improving our overall efficiency. I want to turn to the Obama-Biden energy vision, you know, and I think President Obama has really done a really good job of putting together a commitment to renewable energy resources. He's taken the charge and the lead. He's looking at 10% by 2012. We're well underway to make that. If you remember the other numbers, we had 6 in hydro, 2 in renewables, so we need 2 more, and I'll show you where we're going to get them. And 25% by 2025, I think that's doable if we keep up at the same rates that I'm going to show you on some of our wind and PV and where we're moving. The big number here, 60 billion gallons in biofuels. So if you remember what we saw, we said 150 billion gallons roughly is what we need to drive around. So between ethanol and biodiesel, you know, this is a significant chunk. This is how we're going to reduce our needs for petrochemicals. The other aggressive goal is 1 million plug-in vehicles by 2015 and increased flex fuel mandates. Again, right now, one of the things that's hung up in Congress is the $1 tax on biodiesel, and the other thing is the mandate for ethanol blends. It's capped at 10%, and they're trying to get that to 15, and then that'll gradually go higher and higher. Improves electrical grid. He spent. Moving forward here. Energy efficiency in buildings. He's allocated about $10 billion in that sector. About 4.6 in improving the electrical grid, another important segment. $4 billion in CO2 capture and sequestration. If we're going to have coal, which is about a 250-year supply, we're going to need to do it in a clean way if we're going to move forward here in the future. And so we'll have coal to liquid technologies as well as clean coal technologies have to be demonstrated. Commitment to nuclear. Again, in the federal program right now, the Gen 2 reactors that are out there, you know, they've been around a long time. The Gen 3 is pretty much going for reliability and performance. But the Gen 4 will actually take, and we only get about 5% utilization out of a core. And the Gen 4 reactors will be high temperature reactors. They'll get somewhere around 90% utilization. So if you think about the deposits going out into you know, that we want to bury into the ground, we can actually take some of those and reuse them. So these are technologies that are still 20 years away. Cap and trade, again, trying to take $150 billion, and this one's hung up in Congress as well. But the idea was that you'd have $10 billion you can reinvest over that 10-year period. And again, it'll be interesting to see how Congress, in this partisan, this is, I think, a partisan area. I think both the Democrats and Republicans want to move forward, see the light. And if you actually go, well, I guess I got ahead. On a global basis, so this is the United States, right? So on a global basis, though, we have world demand on energy increasing about 40% by 2030. And if we look, 90% of that growth is going to come from China and India, okay? I shouldn't say 90%. 90% of the growth is going to come from non-OECD countries. 53% of that is China and India. And you can see that oil is supposed to rise to 105 million barrels a day, coal 53%, gas 42%, and coal moves to a higher percentage as well as renewable energy. But on a global basis, that seems like a pretty weak number. And if you look at these numbers, you can see that the OECD countries, and then basically that's the United States, Canada, the big ones are in there, the UK, France, Japan, you know, we're doing a pretty good job of keeping our climate related carbon dioxide emissions in control. But there's going to be some issues here that we're going to have to address on a global basis. All right, so wind. Let's just turn real quick. Don't want to keep you guys more than another 15 minutes here, but global wind power has made a real significant ramp up. If you go back to the beginning of the decade here, you can see we were at about 24 gigawatts and pretty much has doubled 3 years, every 3 years after that. So 47, going up to 93, 159 last year, and with plans to go up to over 200 gigawatts. That's on global production, okay? So it seems like we've got it there. The US is up to 35 gigawatts of production at this point. We've got a couple of major projects into play, offshore wind projects that hopefully the New York Power Authority and the current administration can get approvals to move forward, both in Long Island and on the Great Lakes projects. And of course, there was one that is kind of the showcase one was on Cape Cod, and that offshore project has just gotten approval to move forward as well. So I think we're going to see some increases in offshore wind. The issue with this, of course, is it's intermittent power. As an intermittent power source, you have to have other resources ready to come online at very quickly, and you have to have potentially some battery storage capabilities as well. So predictability is a real key to large-scale wind integration. The International Energy Agency estimates that if we are going to pursue big wind projects, that there'll be additional $1.8 billion in T&D, transmission and distribution expenses, will be needed by 2030. And again, some amazing statistics last year. You know, the United States was great, 39% growth. Look at China, 100% growth. Okay, so they are getting the message as well. On a U.S. wind power basis, you can see that U.S. growth, 2.5 gigawatts up to 35, 2% of U.S. generation. An interesting number is 39% of the new generation that the U.S. put in last year was wind power. And the goal is here to get to 20% by 2030. Texas, of course, leads with 9. New York is down here about at 1.3. We had a wind energy forum on campus about 3 months ago. We came up with a whole bunch of issues of what additional technology areas needed to be addressed. And so these are things that we'll be working on and thinking about going down the road. If you look at some of the largest wind turbines farms or wind farms in the country, you think about this Roscoe wind farm in Texas, 781 megawatts, 627 wind turbines, okay? Size of Manhattan. You know, these are very, very large wind facilities. And there's a group now in Norway that is developing the largest wind turbine, 10 megawatt. And if you look at this cost, that would translate to about $6,700 per kilowatt. And you know, normal onshore is about maybe $2,500 per kilowatt. Offshore might be somewhere around $4,000 per kilowatt. But then this is just a test. You know, the idea is if you could have only 78 of these instead of 627, of course you've got all kinds of potential savings in maintenance and operation and how you would run the wind farm. So we'll see how that experiment goes. Manufacturers, we don't need to go through these other than to say that GE is a big part, and the only one listed on the page in the top 10. Other U.S. players: Clipper Wind Power, Northern Power, Southwest Wind Power is, you know, some of the big guys. So, what about the small wind market under 100 kilowatt? What are we doing there? Well, that's an area that's growing like gangbusters as well. And I know Steve is interested in that, but 78% growth, installed about 17 megawatts. So you can see the scale, big time difference, but it is, you got to start somewhere. There's been a 30-fold growth expected by 2013, maybe get up to almost 2 gigawatts. And the good news here are good news. The entrepreneurial good news, I guess, is 110 U.S. manufacturers, about 50% are located here in the U.S. And Congress has an investment tax credit so that there's an opportunity to take some of these technologies and move forward. If you want to see a list, allsmallwindturbines.com will give you about 60 pages of wind turbines and the various manufacturers that are out there. We do some work in the wind area on campus, helping advanced vertical axis wind turbines, improving design and output, looking at synthetic jets for large turbine blades, and small wind power conversion. So those are some of the projects we have on campus. Let's turn our attention to PV. We have a lot of ex-semiconductor people in the room, so they know a lot about the PV industry. Certainly you start with those same kinds of materials. And you know, you're converting, alternating, and just to make sure people understand, when you generate PV systems, you are generating a direct current, so you have to have inverters, and inverters will turn that current back to AC to put it on the grid. PV global installations, again, nice ramp-up curve here, and again, the U.S. we'll talk about the US here, but in this color. So this is, again, an area that installations up to 22 gigawatts. So again, if we look at it compared to wind, you know, wind is expected to top 200 gigawatts next year, or this year. Again, the leaders, Germany, Spain, the USA, about 2.2 gigawatts. Global annual production is up to around 7. So that's a 52% increase in 1 year. And again, most of this grid is grid connected. So not a lot of residential power, commercial lighting, you know, off the grid type applications. Let's see, the major, one of the major things going on in PV is that the global thin film solar market is expanding rapidly. It's already up to 19% market share. So thin film, and I know the monocrystalline, polycrystalline guys, you know, they have a very good record. They've been out there a long time, and they're working very hard on their cost parity as well. And I think they'll be a player for a long time as well. But thin film does have its mark. Don't need to go through all these per se, but the leaders statewide, you know, California obviously is leading the show here. And if you're real interested, you can go into NREL and you can look at all the theoretical conversion efficiencies of all the different technologies. And again, the main one you're going to see on housing installations are multicrystalline silica cells and thin film, either CAD telluride or SIGs. Okay, those are the three major technologies that are really making the marketplace. Okay. As far as producers, again, from a U.S. standpoint, solar thin film manufacturers, you can see First Solar is one of the majors, and they just announced last week that they've got their modular cost down to 76 cents a watt. That's pretty major. And they've got 1.4 gigawatts of total capacity right now, and some of that's in Ohio. Global Solar is the other one. There's SIGs, 11.7% conversion rate, 75 megawatt plant in Arizona. And then Prime Star, which is the GE partner, CAD telluride, they're in Colorado. And again, you know, this is cost parity and overall fully loaded module cost. One of the key things that investors look at going down the road. Just a real quick, I think one of the real interesting areas in solar is concentrating solar. US is the world leader at 435 megawatts. That picture there, those are guys on this parabolic trough type system. Basically what they do is they focus the light energy on this rod going down the middle, which is filled with an oil. That oil runs out to a steam generator. In this case, it's these are just solar concentrators heating up this area here, which is filled with molten salt. That molten salt will go to a steam generator as well. One of the advantages of this system is that temperature is up around 600 degrees. It can stay there, so when the sun goes down, you still got energy. You can still be producing electricity. And I won't bore you with a lot, but there's been a lot of smaller projects, but there are some huge projects that are on the board, and both in CSP and PV for the next couple of years. 23 gigawatts just out in the west. Some of the work that we do at RPI, again, we've got some professors interested in full spectrum solar cells, also tracking, quantum dot, and biaxial superconductor technology to lay thin films on different substrates. I wanted to quickly talk about ethanol, biodiesel, bioplastics. There was a real good project down in Tennessee, DuPont, to try to make propane diol from corn. They've got a $100 million investment. So again, trying to get these basic building blocks so that we can have our polymers coming down the road. And again, that's going to be coming from corn stock. There's also projects on pyrolysis liquids to get petroleum feedstock and synthesis gas. If you look at the DOE, they're spending money like they're spending a lot of money in this area, $600 million for biorefinery projects in 2009. Why on ethanol? Again, right now it's mandated up to 10%. We need some legislative help to get that higher. And they're holding back, the EPA is holding back on a 15% increase, and they're trying to figure that one out. There's also a lot of different joint ventures going on out there for the VC guys in the audience. And Shell just hooked up with a company in Brazil to produce ethanol. And if you look, Valero just purchased 10 plants here in the U.S. for $750 million. So there's a lot of activity going on. There's a lot of new technologies. Right now, there's 200 plus plants. They're all using pretty similar technologies, but the first cellulosic ethanol plant is maybe coming on in the next year. And then you've got switchgrass, which is another possibility, which is 5 times more efficient. So stay tuned on ethanol. What did I say? The production last year was 11 billion gallons. So if you remember from the beginning slide, we talked about that representing maybe 6-7% of the needs on a 10% ratio. Biodiesel is another key area. Again, soybean oil is really 80% of the feedstock for biodiesel. About 2 billion gallons of capacity, 110 U.S. plants. They're not quite up at the same speed though, and there's also issues in Congress about how to incentivize the biodiesel fuel market. There's a number of companies that are very interested in this area, and if you look, Exxon spent $600 million with synthetic genomics to move forward on algae biodiesel. So that's another very potential great area of investment. U.S. installed capacity, U.S. Hydroelectric. I didn't realize when I went through, I was preparing this for another talk, but the Grand Coulee Dam is the 5th largest in the world. The next one that the U.S. has is the 22nd largest in the world. So hydroelectric is a huge electrical resource worldwide. And in the U.S., it employs about 300,000 people. And surprisingly, when you look at the International Energy Agency report, it doesn't show much growth in this area. But the people at National Hydropower think that there's growth potential from 23 to 60 gigawatts. So, and that's just in the U.S. It is also the #1 pump storage. So if you're looking at battery storage technologies, pumped hydro is actually the #1 reserve electrical power in the U.S. Building efficiency, a lot of work going here. Anna Dyson was the keynote, at the Solar Energy lunch forum a few months back in the spring. And she's doing a lot of work in the wind solar environment. And they're looking at integrated building wind, integrated building solar, indoor air, and water purification systems. She also has a curtain wall out in the marketplace. That is a 8x10 curtain wall that can generate both electricity by optics. She concentrates the sunlight to a triple junction solar cell to create electrical energy, and then can also have passive solar water heating system here as well. This just got put into the Syracuse Center of Excellence new building that they dedicated in the winter. So they'll be ramping up and doing performance studies on that particular module. And the game plan would be hopefully to turn it into something that can go into many different types of buildings. At RPI, we're doing a lot of work in integrated systems research, whether it's combined heat and power, distributed energy, intelligent controls, lighting, energy storage. So again, a lot of different technologies that we're working on campus. And in the materials side, which is another one of our strengths, if you look at crystalline solar cells, thermochromic powders, thermoelectric conversion, all technologies that will be interesting in the future for energy. Solid state lighting, another area. We just had somebody on campus. They're talking about an increase here of, I think, moving this to a $13 billion market by 2015. And basically 25% of all electrical energy is used for lighting. So again, another major area. We have the Lighting Research Center on campus that's doing work. We have our building in the where I have sitting with new LED lights, and so we're running some tests on those as well. And the lighting research looking at DC power grid for building interiors. So actually taking that, your standard lighting is AC, of course, and we're looking at ways to put modules in place for lighting. Okay. We also recently just got the smart lighting research. There's additional work. There's fuel cell work going on campus. For those in the group, understand that, you know, you basically in a fuel cell, you're taking fuel, hydrogen, you're coming into an anode with a proton exchange membrane. You get electricity flowing in one direction, protons go through and combine with oxygen. Out comes water, heat, and of course, you've got to have this very expensive platinum catalyst to make this all happen. It can drive cars, it can drive airplanes, but it's a technology that's a ways away. Stationary market is one major market with less headaches, but auxiliary power units up to, say, 50 megawatts, and UTC and fuel cell energy out of Connecticut are probably the two powerhouses in that area. The mobile market's been played. There's been a lot of work and effort going on in the mobile market, but just recently, Secretary Chu cut off funding in this area, so, and then reinstated it. So we'll see how that's how that all plays out down the road. The technologies, again, that you'll hear most talked about are proton exchange membrane and solid oxide fuel cell. The top two, we do work in all these areas as well in those two areas. So polymers, electrodes, materials, and controls. We have a fuel cell lab, and Dan Lewis is one of our guys there, who's doing some work. The fuel cell obstacles I already mentioned. One is just the ability to get these assemblies out there with good life, and you can see you got 2.5 as much energy to build fuel cell as will be derived from its service life. Don't know if that's really the case. I haven't had a chance to research that. But right now, fuel cell cost is very expensive. You know, you've got $100,000 just for your fuel cell in a car. So for now, that's going to probably take some time to figure out, and we may be a decade or two away from that technology. On the material side, I don't want to take up too much time, but we have a lot of expertise in technology. We're doing work in distributed generation as well. We have this test campus, test bed simulator on campus, and it's looking at how distributed generation would impact a full grid, and what the impacts would be on loads, on sources, the interplay between the two, how to stabilize the voltage. And again, this is in our High Bay area in Johnson, so we're doing some of this work there with solar, fuel cell, and a wind generator. We'll also put on battery storage here at some point down the road. I thought I'd just finish up with clean tech venture funding, since that was a topic earlier, but this market is about $162 billion last year. China outspent us by almost 2 to 1. Last mentioned Tesla, $704 million IPO VC money that happened just recently. And if you look at the, where did I get this from? VC investments in green industry. Oh, it was CB Insights. But renewable energy is a big part of the portfolio. If you look at where the government's spending their money, these are the types of technologies: building efficiency, storage, carbon capture, direct solar cells, and down the road, electrical energy storage, grid scale, building efficiency. So that's where the government seems to be interested in. And if you look at the hubs that they're putting in the United States, and these are major investments, $125 million. First three, fuels from sunlight, operational simulation of nuclear reactors. Again, important because it can take you 7 years to run an experiment. And so these modeling and operational simulations are really going to enhance the capabilities to move that technology forward. And then energy efficiency in buildings. The next big one that's coming is storage, and we think smart grid, and that should be out next year. So I've taken up a lot of your time, but again, we're interested in company-sponsored research. We can bring expertise to bear and look to work with anybody in the room for collaborative research agreements. I appreciate your time, and have a great day.